We're going to take a moment here to find out that the ideal gas law can also be used with stoichiometry. So you can use both of these sweet skills that you've developed recently. And here's an example of where you might be able to combine those. Let's say we have a test tube or a beaker or a flask, and we want to know the volume of hydrogen gas that can be produced when we mix some zinc. We drop the zinc into the test tube. The solid reacts according to this reaction up here. And we want to know how much gas can we collect. Well, usually when we're collecting things like a gas, we're collecting it and we want to know what the volume is going to be. So calculate the volume of hydrogen gas that you make when you react 12 grams of zinc. So it's going to be important for you to map out a plan and to realize, yes, the thing I want at the end is the volume of hydrogen gas, but how can I get there? Well, one of the things I know that I'm going to need, if I'm going to calculate the volume of hydrogen gas, is I'm going to need the moles of hydrogen gas. So that, I know, is going to take PV equals nRT. And I also can see that I have pressure here in atmospheres. I have the temperature in Celsius. I know, of course, the ideal gas constant, R. And if I look around here, the only thing I don't have is the moles of hydrogen gas. So I'm going to need that to put into my equation right here. How am I going to get moles of hydrogen gas? That's where I'm going to use the stoichiometry. In fact, I'm going to have to do the stoichiometry first because I'm going to take the 12 grams of zinc and using my balanced chemical equation, I'm going to turn that 12 grams of zinc into moles of hydrogen and turn that into liters of hydrogen gas. That's what we're going to do. Let's do that in those two separate steps. So here, in the first step, we're going to take the 12 grams of zinc and we're going to take and convert that to moles of hydrogen gas. So we know that 12 grams of zinc, if we're going to convert that to moles, we use this ratio of 1 mole of zinc is 65.39 grams of zinc. Then we use our stoichiometry, and in this balanced equation we see that we get 1 hydrogen for every 1 zinc that we started with. So we're going to look at the units here in our dimensional analysis and see that our answer comes out in moles of hydrogen. And in fact, the answer at this point is 0.1835 moles of hydrogen gas. Now we're going to take that on to the next page, whoop, just like this, and do the gas law part. So in the previous slide, we came up with this plan that we were going to take the 12 grams of hydrogen and find out how many moles of hydrogen that would produce. And we found that that was 0.1835 moles. Now we have everything we need to rearrange PV equals nRT to solve for the volume of our hydrogen gas. We know, of course, we know that R is 0.0821 liters times atmospheres divided by moles and divided by Kelvin. These moles are going to cancel out. The 0 degrees Celsius, of course, we remember that when we're working any kind of gas law problem, we have to convert that to Kelvin. That's where the 273 Kelvin comes from. And we see 1 atmosphere of pressure, and that's where the 1 atmosphere of pressure in our problem comes from. And that comes out to a volume of 4.11 liters of hydrogen. Hey, that could be really useful if I want to make a bunch of hydrogen. I know. Oh, I'm so excited about this, I'm just going to have to quit recording.